Hi, this class we will talk about the short channel effect about on semiconductor. So the on semiconductors history, the semiconductors getting smaller and smaller because um, the wafer size is fixed. So it is in the modern semiconductor industry, the wafer size is like amount like 300 millimeter. So when the chip size getting smaller and smaller, there are we can manufacture we can make more chips on the one wafer, so the company can earn more money on the one wafer. So and when the chip size are getting smaller, the chips speed or like performance getting higher and higher. But there are lots of phenomenon on when they are getting smaller. So we will talk about the lots of effect on the short channel. So the reason why the name is SCE, so the short channel effect. So we talked about the MOSFET. So the MOSFET structure are like this. So this part will be the channel on the MOSFET. So when the MOSFET gets smaller and smaller, the channel will get smaller too. So the first effect will be the punch through. So the punch through is the um, outstanding effect on the short channel. So the MOSFET will be like this. So this will be the NFET. So um, when we use a source and drain N plus semiconductor and the substrate on the P type substrate on it, so the source and the body and the drain and the body will it looks like some kind of PN junction. So there will be some depletion region on it. But uh, as we learned at the semiconductor engineering one, the depletion regions are are larger to the longer to the it is smaller to the heavily doped side. So the source and drain are now heavily doped now. So the depletion region will goes go to the P-type side. So it'll be like this. But in 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 this part, when there are this is now long channel, but when the chip size gets smaller and the channel will be short, the it will look like this. And this part, the charge will be shared. So we talk we will say this charge sharing. So uh actually when there we need to have some gate bias are bigger than the threshold voltage. That is the condition to make the channel on the source and drain side. But in this part, uh, when there are not, it is lower than the threshold voltage, but there will have some channel on it. So there will have some current on this side. So this is like this is what you call the punch through. So the punch through happens because the charge sharing as the depletion regions are getting closer as we have a short channel on the MOSFET. So this is some kind of problem because as we not expect to not current we did not expect to current flowing, but now there are some kind of current flowing. So we expected the off, but there are still current flowing, so the power will be goes up. So this will be some kind of problem. So there are three kind of solution to solve this problem. So the first will be the hollow implant. So I will draw another picture. As I mentioned, the depletion regions are smaller to the heavily doped side. So the easily way to solve this problem are using P plus type substrate on the body side. So when we heavily doped on the substrate side, the depletion region will get smaller on the body side. So they will not having some kind of charge sharing on the channel side. So we can prevent some punch through effect. But there are some kind of problem of the hollow implant because when we have a heavily doped body on the heavily doped when we use a heavily doped body, uh, there are some impurity scatterings or like yes, there will be the impurity scattering on it, so that will low down the mobility. So the current will there will have some poor mobility and the subthreshold swing will get poor. So this will be the problem. So there are the second solution. The second solution will be the SO using SOI substrate on the body. So the SOI substrate will it's mean silicon on insulator. So in MOSFET we use metal on it and the oxide, and we use substrate on a semiconductor on the body side and use M plus on it. But the problem of the reason of the punch through was the depletion region. So the solution will be uh, don't make some kind of depletion region on the bottom, the under of the body side. So we use here insulator on it. So as we learn the capacitance, so the C will be the V Q over V, and this will be the delta V delta Q. But when we get higher bias on it, the this channel side will be fully depleted. So the Q will not change. So there are not some kind of capacitance on the bottom side, and we can make the depletion region goes goes through the body side. So we can prevent this problem like punch through, but this problem have another problem on it. So the problem will be the SOI substrate is expensive to make. So this the that will be the first problem of the using SOI substrate. And the second problem, the when there are current flowing on it, there will having some heat on the channel side. But when we use some normal MOSFET on it, the heat will go through the silicon side, so it goes through the body side, so the heat will be get cooler. But when we use SOI substrate and when we have some insulator on it, the heat can go out and it gets hotter and hotter. So we call this self-heating. So when the channel gets hotter and hotter, there are lots of problems. And yes, that will be the second problem of the using SOI substrate. So the third solution will be the use buffer. So the punch through will be it'll the punch throughs the reason of the punch through will be the like it is like tunneling, so the depletion region and there are like current flowing. But let's draw some energy band diagram of the metal and the oxide and the channel side. So for MFET, it will be like this. This will be the metal and oxide and the channel part, but there are current flowing like this side. So when we use buffer on it, the energy band diagram will like this. So there are like electrons are here, but so it can go out to the body side. So we can prevent some punch through. But there are some kind of problems. So first of all, it is expensive too, like the SOIs using SOI substrate. And there are like some kind of band offset. So but the offset will be was the unwanted band offset. So that will be the second problem of the using buffer. So this time we talked about the punch-through effect on the shorter channel effect. So next class we will talk about the VT roll-off and the VT reduction, or the gate-induced drain leakage, or the drain-induced barrier lowering. Yes, there are a lot of short channel effect. So we will talk about the another short channel effect next class. So thank you for watching my video.